Hello, welcome to this basic mechanics tutorial. So today we'll be looking at a question involving a cable AB that prevents a bar from rotating. The question says that a cable AB prevents bar OA from rotating clockwise above the pivot O as shown in the figure Q1. A. Determine the length of the cable AB. B. Determine the angle alpha as shown in the figure. C. If the tension in the cable AB is 750 Newton, determine its N and T components along the N and T axis as shown in the figure. So this is a very simple question. So we'll go through quickly so that we all understand. Okay, so I've already drawn a free body diagram, and this is how it will look like. So as you can see the diagram, we have our B here, we have our A here, and then you draw your this one. So the 60 comes this way. From this point to this point is O. From this point to this point is B, as you can see. And you can see so this side is O. From this point to this point, so from this point to this point here is B, and then from this point to this point here is B. What we are looking for is AB. So you can say this is our length AB that we are looking for, as you can see. So now we can look for the length AB by using Pythagoras theorem. Now if you look at A, we can find A using what? The Pythagoras theorem, because this side is giving us a 90 degrees, as you can see. So we can find A and B. Then we use it as a general formula to find angle, the length AB as suggested in the question. So let's go and look for AB. So you see that when you take cos 60, it becomes A over the hypotenuse, which is 1.5. So we get our A to be equal to 1.5 cos 60. 1.5 cos 60. So here 1.5 cos 60, when you calculate it, it will be equal to 0.75 meters. Now when you are done, we find for B. B will also be in the same light as sine 60 being equal to B over 1.5. So we have our B to be equal to 1.5 sine 60, and 1.5 sine 60 is 1.3 meters. So after that, we can actually redraw a big Pythagoras theorem and then find the length AB. Now if you redraw it nicely this way, you see that we have a 1.2 plus A, and A is what? 0.75, and then we have a 1.3 over here, and then we have our length AB over here. So you can see that there's an angle forming over here. There's an angle forming over here. There's an angle forming over which is 90 degrees. So we can actually calculate for our length AB using the Pythagoras theorem too. And we can see that what? AB is the hypotenuse. So we know that hypotenuse is equal to root of the adjacent squared plus the opposite squared. So which means that we know that 1.2 plus 0.75 is equal to that's 1.95 meters. So it means that our length of AB is equal to the root of 1.95 squared plus 1.3 squared, and AB is going to give us the length of AB, which we want to find, is going to give us a value of 2.9 1.34 meters, and that will be the length of AB. Very simple and very easy. Let's move on to the next one. Now the next one says we should find the angle alpha. To find the angle alpha is very easy and very not complicated at all. So that one, you will still use the Pythagoras theorem. Now if we are to draw the length again very well, and then we draw this line, then we draw this way, you realize the alpha is here. The angle over here is actually 30 degrees because this side is 60, and we know the length from here to here, the whole length from here to here, and then we also know the length from here to here already. So we know that the whole length from here to here is 1.3 meters, and we also know that the whole length from here to here is 1.95 meters. So we can actually find this angle, this angle over here. That's 30 plus alpha using tan. So you know that tan is what? Opposite over adjacent. So tan alpha plus 30 will be equal to opposite, which is 1.95, over adjacent, which is 1.3, by the angle that we are looking at. So if you look at it that way, we'll find out that alpha plus 30 will be equal to the tan inverse of 1.95 over 1.3, and then our alpha, so the tan inverse of this value will be equal to, when you calculate, you get 56.3, which means that our alpha becomes 0.3 minus what? 30 minus 30. 53.3 minus 30, which will give us our alpha to be 26.3 degrees, and that's our B. So we solve for B nicely. The next question says that if the next question is saying that if the, so let's go back to the question, and then so that we don't get ahead of ourselves. So if you go back to the question, you see that the next question is that if the tension in the cable AB is 750, then determine its N and T component. Now if you look at the angle very well, the N and T is along the OA, so it means that the T will be like the force that is along the OA. So we are going to analyze that very well. So let's go and do the analysis and get to that part. So now if you come here, and then so let's do it on a fresh page. If you come here and you draw the OA, you draw the OA along this, you see that the 750 is coming this way. So this 750 Newton, which is the tension in the AB, which is here, and then we have the T that is here, and then we have the N that is here. But we can actually bring this T here and then bring this N here. If we do that, then this angle, which is our alpha, so this angle is our alpha, and it's equal to what? 26.3, which we just saw for theta. So if you want to write this wall, if you want to orient this wall, then we are going to draw it this way. So this is actually our T. Then we draw this. Then this angle is our alpha, which is 23 point. This one is our N, and this is our T. And we have our 750 here. So it means that in order to solve for 750 in the N and T, it will become, N becomes what? 750. Or let's do it cos. So it will become 750 sine alpha, which is 26.3, which will be equal to 6672.36 Newton, and our T becomes 750 cos 26.3, which becomes 332.30 Newton, and that is our NNT resolved in terms of the NNT axis. And that is it for this question. Very easy to solve and no difficulty at all. We would like to look at another question from basic mechanics, and the question is about a crane tower. So we want to analyze this crane tower and then solve the questions that are associated with them. Okay, so the question says that a tower crane shown in figure K1 was designed for lifting materials at the construction site. A counterweight of 31 kilonewton is exerted at point A. So at this point A over here, there's a weight of 31 kilonewton, and then the motor weighs 4.5 kilonewton. So the motor, which is here, weighs 4.5 kilonewton and is located at a point M. So that's the M over here. And then the weight of the boom, which is AB, which is here, AB, weight of the boom, which is AB, is 36 kilonewton, which is at G, which is here. So the weight will be acting here, 36 kilonewton. And then the weight of the vertical tower is 23 kilonewton. So that is the vertical tower. This vertical tower over here, it has a weight of 23, so it will act in the middle of it. And then they are saying that the length x is the horizontal distance at which the loads are suspended from the center of the crane. So this is our crane, and then we'll be varying the weight according to the distance from the middle of this vertical tower. So we'll be looking at that very soon. Now, it said the length x is the horizontal distance at which the load W is suspended. From so we'll be looking at this question quite simply. So the first part is that we should sketch the free body diagram for the crane and assume D and E to be smooth surfaces. So we can assume them to be reactions that are going on. So let's go and look at the free body diagram. Look at how it looks like. So this is how the free body diagram is going to look like, as you can see. So from the crane, you can draw the crane like a straight line. That will be A, then the O will be the center of the vertical plane, then G and B. And then we are done. We give it a very nice. So here we have our A here, our O here. So this is like our crane. The line will be like our crane, and then we have our forces acting on them. So this one is acting down. The weight 31, 4.5, 36. Then we have our W, and we are going to vary the X. So D and E. So this is the free body diagram. So you can say this is our A. This is our A. That's what we can see. So this is our A. So let's continue and then solve for our B. So let's go and look at B and see what we have there. Okay. So now when you come to B, they said for the recommended maximum W, which is 9 kilonewton, sorry. So the recommended weight is 9 kilonewton. And I think we should determine the reaction forces at D and E for X. So X is varying from 0 to 32 with an increment of 4. And when you go down here, you see the table has been provided. So we are going to fill it in over here when you are done. So you solve for D and E, the reaction at D and E, using the free body diagram. Then the W is 9, and you vary the X to get this value. So let's go and do those calculations and see how they go. Okay, so let's do that calculation for D. So now, when you come to B, you realize that the free body diagram, we sum and we take moment. That's basically what we are going to do over here. So we sum forces and we take moment. So if you come here, and you sum forces in the y direction. So summation of forces in the y direction. So if it's going up, then it's positive, so it's equal to 0. So we can say sum of upward forces is equal to sum of downward forces in this sense. So 31 is coming down, so we can say 31. We can do it everything in kilos, so 31 coming down plus 44.5 also coming down, plus the weight of the vertical distance, which is 23 kilonewton, then plus 36. Then we can also say minus W, so the W also be there, so we can also say minus W 8. So minus W is also coming down, so all these are all coming down. They are all equal to a certain D plus E according to our free body diagram. So if you look at our free body diagram over here, let's go up and look at our free body diagram. You can see that D and E are going up, and then the weights are coming down. So 31, 4.5, 36, and W, they are all coming down. So downward force is equal to upward forces. 23 is also coming down, which is here, as you can see. So D and E are the ones going up. So let's go down again and see what. I'm going to make our calculation. So when you come here, we are going to get this. So we can do D and E in terms of each other is the sum. But first of all, we can write this as a, so we know W to be 9. So if we calculate it, we are going to get a value of we are going to get a value of, so we'll be getting a value of 103, where the W will also be 9. So we can make the W 9 because W is actually 9. So we can just solve for the W and we get our W to be 9. Okay, so let's see how this will work. If I come here, this W is 9. It's 9 in this sense. It means that this value is 103.5 is equal to D plus E. We can choose to make E the subject over here. So let's make E the subject. So if you make E the subject, E is equal to what? E is equal to D. That's E is equal to 103.5 minus D. Okay, we can say maybe this is our equation 1. Then we take moments. We take moments about O. Okay, moment about O means that we are taking the middle ground. You see where O is. So O is located here, as you can see. O is located here. So this middle ground, we are taking moment about this point over here. Take moment about this point in the anti-clockwise direction. 31 will go this way, which is anti-clockwise positive. Anti-clockwise positive. This one will go clockwise negative. So we also go clockwise negative. The distance are already there, so we don't need to struggle to get this one. D will go clockwise. D will go clockwise and E will go anti-clockwise. So we have D and E interchanging each other. So let's go and look at the moments as I've explained here and write them. So taking moments, taking moments in the anti-clockwise direction. So anti-clockwise is this way, right? So anti-clockwise direction to be positive. So if you take moments about the O to be equal to 0, you are saying that anything going clockwise is what is positive. So 31 is going clockwise. So 31 multiplying, that distance from O is 5 meters, then plus 4.5 multiplying 3, that's the distance from O, multiplying 3, then we have minus D, which is going clockwise, multiplying 3 also, and then plus E multiplying 3, that's going anti-clockwise, is positive. Then we have minus 36, because going clockwise, multiplying 6. Then the final one will be minus w multiplying x. That's the distance from the O, and is equal to 0. After solving this, after going through the rigor and everything, we are going to arrive at an answer where we get to, where we are going to get 3e minus 3d is equal to 7.5 plus wx. So 7.5 plus wx will be the answer that we are going to arrive at. Now, when we are done, we can make here, we can input equation 1 into this. So bringing equation 1 into this, then we have equation 1 is 103.5 minus what? Minus d. So we can say 3. So e is equal to, so we can put e here, sorry. So we can put e here. Okay, so we can put e here and say, okay, so 103.5 minus d, that's e, then into bracket minus, minus 3d is equal to 4.75 plus wx. So if you have that, then we can say that when you summarize this, you realize that 6, so we'll get everything to become, so this one becomes 0.5 minus 3d is equal to 47.5 7.5 plus 47.5 plus wx so 47.5 plus wx. So now if you do this correctly, if you do your algebra correctly, you are going to get 6d is equal to 263 minus wx. So it means that our d now becomes 263 minus w is 9, so we can make it 9x. W is 9, so we can make it 9x over 6. Then for every value of x, you vary them. You're going to vary x. Okay, so I'm going to do at x is equal to 0, our d becomes 263 minus 9 into bracket 0 over 6. Then you get your d value. So you're going to get your d value to be 43.83. Then if you want to get your e value for this one, you are going to do, that's 103.5 minus 43.83, and that value is going to be 59.8. sorry 5059.67. So we are going to do that for x is equal to 4, x is equal to 8, x is equal to, so up to x is equal to 32 with the intervals of 4. You get that? With the intervals of 4. So after doing all this, you are going to get values for d and e in terms of x, all the x. Then you plot them. So that's basically it for this question. Okay, so let's move on to the next question and see how that one too also goes. Okay, so the next question says that we should, so the next question which is C, said for the recommended reactions of 4.5 kilometers, meaning that D and E have reactions of 4.5 kilometers here and here. So with that reaction, they said we should determine the lift loads W that the crane can lift without rotating. So we don't want it to rotate, so we want to vary x and determine W. So it means that W is the one that will be changing. So W is like a dependent variable in a way. So we want to vary, and then x is the independent variable. So we want to look at that. We want to solve in terms of x and then vary x to get our w's, that's our outputs. So let's do that. So that one is very simple. We will still use the free body diagram. So let's go. We'll still use the free body diagram to get our answers. So let's see how we do that. Okay, so basically when you come here, this D now becomes 4.5, then E becomes 4.5. So everything has value except W. So we don't know W now. W is not 9. W is what we don't know. So we are going to vary W. So we are going to take moments about O, then we vary W in terms of x, and then we do that. So let's take moments in the anti-clockwise sense. If we take moments in the anti-clockwise sense, it means that 31 is positive, so 31 times 5 plus 40, 4.5 times 3 from the O, then what, minus 4.5, which is this D times the 3, then what, plus, which is anti-clockwise, the E times 3, then the G is also what, 36 times, minus 36 because it's clockwise, so minus 36 times 6, then the W is also what, clockwise, which is minus, so minus Wx, the x is the distance, so moment is what, force and that's from the O, and that's how that one works. So we do that and we vary the W. So let's go and do that, and we vary the W so that we can get all values of W. Okay, so basically you take moments, so you take moments about O, about O. Okay, so you take moments about O in the anti-clockwise direction. Okay, in the anti-clockwise direction. So let's do that. So if you do that, 31 is going anti-clockwise, so it will become 31 multiplying the distance, which is 5, then plus 4.5 multiplying the distance, which is 3, then the D is what, minus, so that's also 4.5, the reaction 4.5 which they give us in the question, then times 3 from the O, so times 3 from the O, then we have another plus 45, which is the E, which is going anti-clockwise of 3, then we have what, the weight itself, which is 36, multiplying what, 6 from O, then this minus rather, so this side is minus, this one is minus, and this side is also minus W, multiplying what, x is equal to what, 0. Now when you have this way, then we are saying that we can make W the subject over here. When you do everything, you are going to get negative 4 7.5 minus wx, and then wx is equal to 0. Then you are going to get w to be equal to negative 47.5 over x. The negative just means that the direction we choose means that negative just means that we are in the clockwise. The direction we chose was just wrong. So it's not any the weight is acting down in a way. That's the meaning of the negative. It doesn't really mean anything tedious. So now let's go and vary. So when you take x is equal to 0, you can see that w is infinity in a way, because any number over 0 is infinity, so you cannot do that. But if you take w is equal to 4, if you take w is equal to 4, you can say w is equal to what? 47.5 over 4, and that will give us a value of 11.88 kilonewton. So we do that, we get that. Then if x is equal to 8, then we are going to get 47. We are going to get 47.5. I'm going to get 47.5 over 8, which is equal to 5.94. So you do it up till 32. So you continue the rest till 32, and then you get your values. And then there's a part of the question that says we should plot. So that one, you use your graph to plot. So your y-axis, so your y will be the load. So you plot. So it means that we are going to do 3 plots. So w against x, d against x, and e against x. So x is the distance 0 to 32. So with the plotting, you can do this. You can just draw your y. So if you have a graph with you, I don't have a graphic, but I'm just demonstrating what you do in the plotting. So this will be one plot. So w and then x in terms of meters. So x in meters and w in what? There's a kilonewton. So you found some w's, right? The w's you found, the w's were varying. So you vary them and then you draw the graph. So maybe you get a graph like this. So these are you label, because this one the maximum is 32. You can do 0, 4, then you can do 8 here, you can do 12 here. You label them, and then the w2, you look for the highest w number. When you solve correctly, you are going to get the highest to be 11.88, and then the lowest to be 1.48. That's for the w. When you solve it correctly, then you plot them here. Then when you are done, you plot d against x, e against x, and then you get that. So let's look at the last question, and now let's go look at the question over here. So they said that from the graph, determine the safe load that can be suspended for long periods. So safe on the bloom. So the bloom is AB. Okay, that's the whole horizontal crane. That's the bloom. So they are saying that we should determine the safe load that can be suspended for long periods. So W, remember that the first time the recommended load in the B was 9 kilonewtons, which means that if you solve, you will see that at x is equal to, from x is equal to 8 to x is equal to 32, the loads are safe because they are below 9 kilonewtons. So the loads will be from between 5.94 kilonewtons to 1.48 kilonewtons, which means that they are safe loads. Which means that those are the loads that are safe. So when you solve them well, you see that from distance 8 meters to distance 32 meters, the loads are safe. And then they said F, what can you say about the loads? What you can say about the load is that the further the distance, the load from the middle of the vertical crane the safer the load. So the further away x, the safer the load. That's what we can say about F. And that is the solution to this problem. Thank you very much, and I hope you subscribe to our channel. Bye bye.